Welcome to Best Practices for High-Performance Tests, brought to you by Forge College. In our last session, we used per-test gas reporting to hunt down and patch some serious smart contract gas hotspots. Getting those numbers down was a major win. But here is the reality of smart contract development. You fix a hotspot today, and 3 weeks later, your test suite is crawling again. Your gas reports look like a random number generator. Measuring performance once without a system to persist those gains leaves your suite vulnerable to regression. Finding a massive gas leak does little if the next code commit can quietly reintroduce it. We need a system. To build that system, we first need to isolate the target by stripping away gas noise. Gas noise is the unnecessary setup cost, drowning out the actual execution cost. Measuring efficiency while including this giant setup gas is like calculating a car's miles per gallon, but accidentally including the financial cost of paving the highway in your final number. The solution is a standardized checklist. Think of this checklist as a series of technical filters designed to strip away the testing bloat. We cannot protect our smart contract's performance until we isolate its true gas cost from the messy environment we tested in. This processing funnel diagram shows our checklist in action. The first filter enforces a minimal setup routine. We have to stop deploying the entire universe just to run a single test. We initialize only the exact state the specific benchmark needs. As the code moves to the second filter layer, we target redundant deployments. We replace repeated full contract deployments with shared fixtures and state snapshots. This reduces the massive gas fees incurred before a test even starts. At the third filter layer, we mock out external calls. Relying on expensive third-party protocols introduces fluctuations. We replace them with lightweight controllable stubs or direct state writes. At the final filter, we cut the execution bloat. We limit heavy on-chain execution loops, moving them off-chain or using indexed helpers instead. Applying these 4 filters systematically transforms a chaotic test suite into a clinical environment, giving us a mathematically pure gas baseline. Once we have that pure, filtered signal, we isolate it. We place the isolated function into a dedicated tests/benchmarks folder, separate from our standard daily unit tests. Now, a strong warning: never hardcode specific numerical gas limits directly inside your Solidity test code. If you hardcode a limit like must use less than 50,000 gas, minor compiler updates or valid optimizer tweaks will alter the cost. Your test suite will fail and your team will waste hours chasing ghosts. Instead, use the benchmark test strictly to assert functional post-conditions. Prove that the math actually worked and that the state changed correctly. Let your external tools handle the actual gas measurements. The Solidity test file's specific job is to guarantee the contract behaves correctly. We let the broader system architecture take responsibility for judging its performance. We route the pure gas metric directly into a version-controlled baseline ledger. Next, a CI pipeline adds automation. Every pull request submits a live gas metric into a comparator gate. If the gas spike exceeds a pre-approved margin, the CI job blocks the deployment pathway. Sometimes gas increases are necessary for new features. If a developer intentionally increases gas, they must update the baseline file and justify the increase in their PR notes. By transforming gas measurement into an automated CI policy, you eliminate silent regressions without slowing down the daily agility of your development team. Establishing these isolated benchmarks prepares us for the next step. In the upcoming capstone, we will map these exact CI actions directly into your final repository. This video was brought to you by Forge College. To dive deeper into smart contract testing and master Web3 development, visit forge.college. Maintaining an automated discipline keeps your suite optimized far longer than any one-time bug hunt. Catch you next time.